Hi. It took a couple of months that I could actually come back and make another video. I'm sorry for that, guys, but I was really busy with this project that all this Servo Heater. So basically, it's a project that has made me very busy recently. So the idea was that we don't need to heat up the whole building. So a kind of a servo heater that can follow the person inside the room and find its location and warm up only that specific location could be sustainable and could save cost and energy. So um, to flourish this idea and to work on this idea, I have invested some time. And this machine basically works by based on vision based, is like based on camera. And in this video, I will show you the final performance. It's not really final, but it has got much better. So I will show you what are the components, what are the codes, and what could be done to optimize it, and we will review it together, the performance. So yeah, let's do it together. So as I promised, let's see how it works. So at the moment, I will show you the machine. So basically, this is the machine that is behind me, and there is a servo heater, a motor that moves the servo right and left, and at the top, the head, there are also two servo motors which define the orientation, basically. So I have connected everything here via Raspberry Pi, and the Raspberry Pi, as I told you, explained in another video, how basically the hats are connected, and it will move this guy to the right and left from this position, which is run by DC motor, and to the end, which are controlled by switches, and in the middle, basically. So basically, there are three location or position, defined position for the machine to stop. And the basically Raspberry Pi works as a server, and I have connected via OPCUA and Ethernet to this site, which is basically my Python code as a client, and I would like to see how it works. So at the top, basically there is one camera. I mean, the one that's not left side, the right side is also Raspberry Pi. It's also connected via Ethernet to the server. So all the data are taken from this one, and is that when I implement the code, it should automatically detect my position, and if it should move toward me and start the heater. So let's run this code. So I will basically come here and run it. All right, the code is basically start to, yeah, it's basically detected my position and moved to the location that I am. So to define that position, I have basically used some preset data, and I have for this system, for the new system, I've used Yolo and neural networks because it's much more stable and it takes much more. It's not perfect, but it's in comparison with Hug descriptor algorithm and Hard Cascade, it is much better. The previous version, I had to tackle the disability or instability of the algorithm. I had to install two Raspberry Pi camera, the corner, so one camera at this side and one at the other side. I don't know if you guys see it, so it's behind the curtain. So this was the idea, and but now only one camera, and because with this Yolo, the model is much more, I would say, stable. And now, of course, like during daytime and when there is a better light, the model works better. But at night, but right now it's night, so the model is a little bit lagging. It's not really that much accurate, but still much better from the other, basically, yeah, the algorithm that I see. So let's see if we move to the middle of the room, if it will follow us. Uh, so yeah, it moved and it should stop in the middle. Yes, so basically it's exactly behind myself. So it move and then move again to the completely left side, and I expect that the algorithm detects my position at the left side and follow me at the left side. So as you hear, I have some mechanical problem there, but it is part of the uh, project, which are basically a very cheap component that I have. But the machine works fine, it's accurate, and I can say that I'm basically happy with the results so far. So I will move back again to the position that I came, basically here at the end. So again, the machine should change the position and move uh, basically to this new location. It's a little bit slow because I have put a little bit delay and time and to basically make the machine more relaxing. But at the end, I think it works fine. And yeah, there are a lot of wires. I'm always a little bit concerned about these wires, but basically it is good. I think the next step for me would be basically I try to, because as I said, I use basically preset values to define the calibrated, to define the calibration for the machine. But the next I would use this camera as you see, and for the head of the machine, the head of the servo, I would like to use some kind of regression model to automatically, the machine automatically finds where I am, not the other one that I just give some raw data and predefined data. So that would be the next step to develop the model. But it would be very, very then accurate. It will exactly find the center of my body, and it will point at that point. So that would be quite so. So as you see, this project is some kind of a mechatronic project between between servo systems, Python programming, electrical installation, and also electronics and Raspberry Pi, which I'm really happy to have it at home. One more thing that I would like to also mention, maybe in my blog, I had written some not so satisfactory codes for the Raspberry Pi, which is basically also based on Python and Python circuit. And I asked actually Chat GPT to optimize this code, and he optimized it for me very, very nice. Not perfectly, everything was not perfect, but 80% was very nice. New methods or new way of coding. I learned a lot, and I used that code. And before that, not optimized code caused the CPU of the Raspberry Pi to get stuck to 100%, and basically everything was stuck, didn't work after a cycle, several cycle. But now, basically, it is after optimization. The code is very nice. I will show you this code on my weblog. Please like it, subscribe it, comment it if you enjoy this podcast. I try to basically brings up whatever I learned and represent it back to you in a positive way. So I hope that you like it, guys. Thank you.